This is another one of the video lectures for tutorials. The topic of this is under gas laws. I'll be doing an ideal gas law calculation. The problem I'm going to go over is actually from page 7 of your homework packet. Page 7 of the homework packet, I'll go through the first one there. So these are calculations with the ideal gas law. It says how many moles of carbon monoxide will exert a pressure of 73.176 kilopascals in a 1740 milliliter container when the temperature is minus 12 degrees Celsius. Okay, so I'm going to put up one of the larger pieces of paper so I can work through this more slowly. If there's anytime there's not enough space for you in your homework packet to do the problems, you should always add extra paper. Okay. So first let's write down the information that we have. My question is how many moles? So N is what I'm looking for. I have 73.176 kilopascals. That's my pressure. And my volume is 740 milliliters. And temperature is minus 12 degrees Celsius. So there's a couple of values that we need to change from the start. Right? We can work in kilopascals, that's fine. But when you're using the ideal gas law, you have to use volume in liters. So we have to convert these milliliters to liters. And the equivalent is for 1,000 milliliters, there's 1 liter. So this would come out to be 1.74 liters. Temperature, of course, has to be in Kelvin, and this would be 261 Kelvin. So the equation we're using for the ideal gas law, PV equals nRT. In this case, we're trying to solve for N, number of moles. So you want to divide each side of the equation by whatever's next to N so that it cancels out. Alright, so I'm going to divide this side by RT, this side by RT, so that this cancels. So I'm going to flip it around too as I rewrite it, just so I have N on the left. So now we have the formula to work with. Move this up a little bit now. Pressure is 73.176 kilopascals. My volume, 1.74 liters. Now when you substitute your R value, remember you have to choose the correct R value that will meet whatever pressure system you're using. Since we're using kilopascals, then the R value that we use is the one that uses kilopascals, 8.314. And the units that go with that would be liter, kilopascal, over moles, temperature. And then the temperature for this problem is 261 Kelvin. When you put all that in your calculator, you would get 0.05867 moles. And you see the answer on your homework packet says that it's 5.87 times 10 to the minus 2 mole, just putting it in scientific notation and in 3 significant digits. All right, you always have to keep track of the significant digits. So the least amount of significant digits we had up here was 3, so your answer can only be in 3 significant digits. So there's a very good example of doing a calculation with the ideal gas law.